welcome to Earth Engine tutorial episode 41. In this video, I'm going to show you how to develop an Earth Engine app to analyze landscape changes, for example, surface water, vegetation, or urban. Anything that can be quantified using a normalized difference index. Let's get started. So first of all, you need to go to my GitHub repo to download the notebook examples. Once you get to the repo, you can go to examples, notebooks, scroll down to C number 41. Once you get here, click the raw button and then right click save as. You can save this one to your computer. So for me, I'm going to save this one to my downloads folder. Now the notebook has been downloaded to my computer. You can then open the terminal to start Jupyter Notebook. Make sure that you activate your contact environment where GEmap is installed, and then just type Jupyter Notebook and then click the link. So we have the notebook. Double click. It should open the notebook on your browser. And we're going to go through this one step by step. But first of all, I want to show you what the app looks like. So you can click the link here to open a new tab. And so this will be the final product. Behind the scene, this all the source code here basically used to create the app. And you can look at this one. Essentially, it's a notebook, and it executes all the source code, and then this will be the final output. If you want to learn how to deploy the notebook, you can look at my previous tutorial. This tutorial will just demonstrate how you can create the app, but if you look at the links in here, these are links that you can deploy to the web, and then you can send the links to other people so that they can go to the URL and to visualize the app without having to look at the source code. So if you want to learn how to deploy the app, you can go to my check out my other tutorials. I think it should be number 26 and 28. So 26, how to deploy the app using Heroku. You can also deploy the app using your local computer as a web server. So make sure you do check out tutorial 26 and 28 if you want to learn how to deploy. Okay, so this is the app. If you see from here, this is the URL, deploy using Heroku. And look at the instructions. So first, you can pan and zoom to any location, or this one here is the US counties by county level. And you can zoom to any location you want. After that, you can click on the map. Since my internet is a bit slow, bear with me. So for example, if you zoom in to certain location, this is in North Carolina. And once you zoom to the location you like, just click your mouse on the map. It will automatically select the county. On the right here, you will see the name of the county, right? And you can also see that one here from the lower right corner. If you click on other location, it should automatically change the location. So you will see from here the other county, and also here also change. Let me get back to this one. Once you select the county, then you can change the options in here. You don't want to use this one because for the first case we're going to just use county level, and you can check the download chart data because we're going to do time series analysis from 1984 all the way to 2020, 37 years of Landsat data. And once we select the county, we want to do the statistics. In this case, we're going to do extract surface water. So we're going to use the modify water index, and you can adjust the threshold if you want. And I'm going to check this one. So for example, I'm going to adjust maybe to 0.1, and then blue color represent water. So after that, just click submit. Then behind the scene, the algorithm is you go to Earth Engine to retrieve all the data, and then to do the Landsat time series annual composite. And once you have those 37 years of data, you can use the normalized water index to extract surface water. And you will also do the computation to automatically calculate the statistics and then plot the temporal trend here. And so you can download the data. It might take up to 1 minute. Okay, so now you have this one. Keep that in mind, this is only 1 year. So selected year 2010. You can adjust the slider to any year you want because we have 37 years of data. You don't want to display all 37 on the map. So we just select any year you want, and you should have this one here. You can zoom in to see the details. Keep that in mind, this is just a demo, okay? So it's not going to be perfect, like exactly the result 100% accurate. Just a simple demonstration. You can change this one, for example, to vegetation if you want, if you're interested in mapping vegetation. Okay, so now we have this one. You can see the plot here on the right from 1984 all the way to 2010, and you can see that the surface water area is actually decreasing through time. So, and you can click this one, you can zoom in to see the details, right? 2012, 2002, 2003, 2004, right? You can zoom in. You can use this one to reset. You can download this one to your computer as a PNG if you want. And more importantly, you can download the raw data. So each year has a number, a value, like representing the area, hectare. So you can click this one and then download this one, for example, to your computer. And from here, we can open. Now you can double click to open this one on your computer. So hit OK, and then open this one. So you can see the values. Okay, the first column represent the time, and the second column represent the area. So 1984, and you can see the hectares all the way to 2010. You can do this one for any location. Okay, so not just for this location. Similarly, I can switch to, for example, do vegetation, and you'll be the first pane. If the excuse me. If this is nothing, like the spectral index is not in here, you can use customize, and then from here you can select whatever you want to do. So I'm going to select, for example, vegetation, and again you can adjust the threshold if you want. Let me do maybe 0.2, and for vegetation I want to use the color, maybe green color to represent, right? And just to submit, and it might take up to 1 minute. Usually it should be 30-40 seconds. You should be able to get the results. And this one here, actually the data are the same as we used to extract water. So with the same data, but we just apply a different normalized difference index. So you can still see this. Right now it's 2011, and we will see like when the result is displayed, because the first example we used to extract water. Now we do the opposite. We want to extract a vegetation. So you can see from here, now this is green color and it's all vegetation. So the black color is water area. So those are not vegetation. You will also see some of these transparent area. Those are most likely removed due to cloud. So no data area. And similarly, you want to see the statistics here. The plot here on the right once the computation is finished. So you can use that to download the data to your computer to do other plotting if you want. Okay, now you see this one. As you can see here, this I preloaded the US counties layer. If you want to use other layer, you can customize the source code. I will show you the source code later, but let's move to other location that is outside the US. Okay, so now we can switch this one. Use user zone AOI, area of interest. So you see here, once I click this one, it's automatically removed. And we can move to, for example, here, this location, and take a look at, for example, something like this. And since we already enable this option, now we can use the drawing tools in here, and we can draw something like this, right? You can change the layer control, the band combination if you want. Again, you can switch the year. So let's see, maybe 2018, and I want to extract water, right? Again, you can adjust the threshold, be 0.1, and I change to blue color, and just hit submit. And you should be able to get excuse me, the result pretty quickly. You can zoom in to evaluate. You see here, pretty much very close, not perfect, but you get the idea. On the right here shows you the plot. Again, you can download this one to your computer if you want. As you can see, very easy to use, simple and straightforward. Users don't have to know how to do the coding. They can just go to the URL and then they can explore the app that you develop. So next, let's talk about how this app was developed. So if you want to customize the app, you can certainly welcome to, but you need to do some modification to the source code. So next, let's go back to the source code, see why. Let me do the side-by-side comparisons. Okay, so this one is on the right. Let me do it in here. And let's go through step by step. So just to show you how this app was built. So first of all, you will see here in this notebook, we have two different types of code blocks. So this one here is Markdown. You will see from here, Markdown basically is text, or you can display regular text. You can display hyperlinks. And double click to see the Markdown, original Markdown. Again, if you execute, this is what it shows after you render the Markdown. So you can have hyperlink, you can have images, you can also have videos, and the Markdown will be executed, and you will show it in here. So this one comes from here on the left side. Next, these are all the source code. So the source code won't be display. It will only display the output. You can show the source code if you want, but in this case, we're just showing the output. So let's go through step by step in here. Let me click this one, execute. This will just check if the Gmap is installed or not. If not, it will install the package. Then we can import the library. After that, we create a map and then add the layers, add the two different layers. So this is what you saw earlier. You have the base map. You can also have the US counties, and so let's execute. And you will show the map here, right? The US counties. If you want to customize the map to use for other countries, you're also welcome. So all we need to do is just to replace this one with your feature collection, and you can also change the layer names if you want. Once you have this one, then you can use that for. I also have the US states. Probably this one is not needed. Or it's needed because later we use the county to retrieve the state name. So both two layers are needed. Once we have the data and the map, so the next step is to create this interactive widget. For example, text box, checkbox, and also, for example, band combination, different year. So this is where all this long list of code is designed to do. It says you to create those interactive widgets. I want to quickly go through. So if you see from here, output widgets, this one is the most important one because this is the way you see the plotting at the lower right corner is when it's being plotted to the map. So how can you add something interactively to the map? You can look at my previous tutorial, number 40, where I show you how to add interactive widget to the map. So basically there's 3 steps. First, you need an output widget. So this one comes from the IPy widget library. And you also need a widget control. So this one comes from the IPy leaflet. And the widget control has 2 parameters. The first one is the widget. The second one is the position. So you can change this one to bottom right, upper left, or upper right, or bottom left. And so this is why you see the chart earlier that you display at the bottom right. And this is very important because you can display text or any widget you want. Next, admin1 widget. So it's this one here, the state. Admin2 is the county. AOI widget, this one is the checkbox. You see from here, this is the one where this the checkbox widget. You can also download the data, right? Also pay attention. So this is like AOI change. If you see from this one here, once you check the checkbox, it will clear all the output. So you want to remove the layer and also reset this one to empty, because earlier when you see like when I have the US states, right? So if I click here on the map, it will automatically populate the contents in here in these two boxes. But if I just click this one, it should automatically it's still running. You see, once I click, it's automatically clear the output. So this is what this function is used for. It's monitoring the user input. If the user check this one, you're going to change this one value to none. Also the drop down list, right? You can see from here, the year widget, the F mask. Similarly, you can go through those widgets. And lastly, this is where you can display the output, right? So those widgets, before you explicitly call them, they won't be displayed. So this is where we can use so-called VBox, vertical box and horizontal box. So you will see here we have multiple lines, right? Multiple rows. So the first row, second, third, right? And those are so-called vertical. So, and even in each row, you can have multiple, right? Combine them all together. So 1, 2, 3, 4, and you can put them as a list. This is where you see those widgets, right? See me in here. Let me maximize it to see, make it very clear. Lastly, these are the two functions that are very important to monitor the changes. So the first one here is the handle user interaction, and this one is user interaction on the map. So if you go back to this one here, what do I mean by user interaction? So when the user moves the map, whenever they click, you see here, the type is equal to click. When I click on the map, it's going to retrieve the user coordinates and then use the coordinates to filter the image, the feature collection. Basically figure out which polygon, which county the user click. So if I click on the map in here, it might take some time to execute. Probably app is inactive right now. Let me go back to here, use this directly, use this one, right? So when I click on the map, oh, I haven't sorry, I haven't executed the code yet. So make sure that you need to execute the code, otherwise it's not monitoring the interaction yet. I'm going to also execute this one. Then let me come back to here. Okay, so now when I click my mouse, it's going to change the cursor, and you will see in here it automatically populate the county. So if I change to the other one, it should change automatically. Also, you excuse me, you should see on the right here, also the state and the county name very similar. So this one is what this code block is used for. It's used to retrieve the user location and then figure out the county, and then retrieve the name of the state and also the county name. Lastly, this is where all the calculation is being done. Basically, first you need to retrieve all the values that the user has selected. So those are the values from the widget, and depends on whether the user select by a county or is it our area of interest, and then it's going to retrieve the polygon and then get the geometry. Once you have this one, it's going to pass into the length time series. So this is the function used to create annual length composite. And you can, after that, you can do the normalized difference index, right? So the user can select band 1 and band 2. And lastly, it's going to show you the result. So the result is using based on this one, set a threshold, get all the results, and then it will only display one specific year. So it depends on the year that the user select, and after that it's goes to add the data layers to the map. Last step is to calculate the area. So just do the plotting. So this is the function used to calculate the area, and then you use the map function and retrieve all the values. And this is where, if you want to download the data, if the option is enabled, we download the data to your computer, and you can just click the link. So one more time in here to show you. If you use the draw RI, it will automatically clear the state, and then from here you can draw anywhere. Okay, it can be a rectangle, it can be a circle, it can be anything, right? So from here I just draw a circle, and then you can change the bank combination. I still use the water index. Click submit. It's take pretty quickly, right? You change the color. Now let's blue represent water, and you see the chart pretty quickly. Keep that in mind, it might not be 100% accurate. This one probably some problem. It might be cloud, or it might be something else. So make sure that you check the data. It's just demonstration. It's not going to be a perfect algorithm for extracting surface water. Okay, that's all for this tutorial. If you enjoyed this video, please consider hitting the like button and subscribe to my channel. Hope to see you in my next video. Take care. Bye bye.